Hello everyone, I welcome you all to the Different Division platform. Right now I'll be doing one such question that came in your NEET examination. This question came on NEET 2019. So let us see this question first. Question says a mass small m is attached to the thin wire and the wheel in the vertical circle. The wire is most likely to break. Obviously, if this is the wire and a certain mass small m has been attached and it is moving in a circular track just like this. Okay, and let this be the base. Okay, and this it is moving just like this. So where it is most likely to break at which point? The mass is at when it is at the highest point, when the wire is horizontal. When it is at the highest point, when the wire is horizontal, the mass is at the lowest point. When this mass is at the lowest point, the answer is third option, because when it is at lowest position, so it is in continuous circular motion. Let v be the velocity with which it is moving in a circular track. So at this particular point, at its lowest point, the weight is acting only downward. At the same time, the centrifugal force mv square by r, where L is the length of this wire, so mv square by L, this is also acting in the downward direction. Okay, so these two will be the force which is balancing its normal. Okay, so the normal force at its lowest point must be equal to mg plus mv square by L. So what about at its highest point? At its highest point, outward centrifugal force is mv square by L. Okay, and the weight is mg. So what would be the net normal force at its highest point? It is nothing but mv square by L minus mg. So this is quite less as compared to the normal that we are getting at its lowest point. At its horizontal position, the weight is acting downward, okay, and the outward force is mv square by r. So the normal at this particular point must be equal to mv square by r. Okay, so this is also quite less as compared to the normal that we are getting over here. So the maximum normal force that we can get is at its lowest point. Okay, I hope this question is clear to everyone. Thank you.